So in this chapter, you're doing log and their properties. Now, you need to know how to convert log form to index form and index form to log form.
Yeah.
So when we have b raised to x is equal to y, your b is for base. So b is the base, x is the index, and y is the answer.
Yeah.
So then to convert this into log form, log y to the base b is equal to x. So what we can remember is before b raised to x is equal to y, so if you take log y, the base will become the base. The base will become the base down, and your x will drop.
So your x is the exponent. Well,
your x is your answer basically. The power will become the answer.
Okay. So I was looking
and log
at
y to the base b.
Yeah. So basically everything just moves. So the exponent becomes equal to, and the base becomes the exponent.
Correct, like this one.
Yeah.
This one, if you want to write a log equation.
Yeah.
So what will you do?
So you take b.
So what is the base over here? The base becomes the base for log. What is the base? 2 is the base.
2 is the base. Yeah.
That will become the base on the other side.
Yeah.
So log 32 to the base 2.
2. Yeah.
Is equal to 5.
To 5.
The power will become the answer.
Yeah.
And the base will become base on the other side. This one.
This would be.
What is the base? First recognize the base.
The base.
What is the base?
9.
Yeah.
So log
3 to the base 9.
Yeah, log 3 to the base 9. Yeah. 1/2. Yeah.
So the power drops. You remove the support, no?
Yeah.
You remove something from the
You remove the 1/2.
Yeah, you remove the 9, therefore the half which is hanging will drop.
Yeah. Yeah.
It's like that. You can think like that. And remember the base will become base on the other side.
Yeah.
Now this one. What is the base over here?
9.
So it will go on the other side.
Yeah.
So you push this up, and drop the log. It's the reverse of that.
So you brought that 9 up, and then you changed that 1. You brought
made
the
a 1 as a power.
Yeah, made that as a power. Okay, yeah. That makes
Next,
sense.
this one.
So you take the 5, you take it on the other side, and then you push the minus 2.
Correct. You push the base, and because of that, this also gets pushed.
Yeah, so it becomes, yeah.
You think like that?
Yeah, it's a nice way to think.
It's a nice way to think. So what are you doing? You're pushing this, and you're pushing this base.
Yeah.
Push the base. And remember the base will become base on the other side.
Yeah, right. So, and then they'll be equal to each other.
Yeah. Just remember that, and you're dropping the loads. So you need to do a lot of practice on this.
Yeah, definitely.
Now evaluate the logs. Hint: set the log expression equal to n. Switch to exponential form, and then use your knowledge of exponents. So important. So what we'll do in this case is you call it equal to n. Let the answer be n.
Yeah.
Chalo. Now convert this into index form.
So the base is 3, and I have to push that up. So is it 3? Is it 3 to the n is equal to 81? Correct.
81 is equal to 3 raised to n. Now 81 is what? 3 raised to 4 is equal to 3 raised to n.
Yeah.
Therefore, what is the value of n? 4. Simple.
Yeah.
Next one, b.
Log 2.
N. You call it n. You're finding the value of log.
I have to find n. Yeah. So you
call it n. You let it be n. Now.
So you bring the 2.
Push.
You push the 2 up to the other side.
And drop the log.
Yeah.
And then n goes up.
Yeah.
64 is?
2 to the 8. No, sorry.
So 64, you find a prime factors. Yeah. 2 3s are 6, 2 2s are 4, 2 16, 2 8s, 2 4, 2 2, 2 1. So how many times? 1, 2, 3, 4, 5, 6. 2 raised to 6, 2 raised to n. Yeah. So n is equal to 6. And to remove all guesswork from your work.
Yeah.
Next one.
So this would be
call it n.
N. So then you push the 10.
So
10n.
So this is 1 upon 1000.
1 upon 1000.
Is equal to 10 raised to n.
10 raised to n.
You're pushing this, correct?
Yeah. So n is equal to
10 raised to minus 3. Equal to 10 raised to n. So therefore n is equal to minus 3.
Yeah.
Follow?
Right. And minus because Yeah. Sorry. Yeah.
Bases are the same equal to index.
Yeah.
Bases are the same equal to index. N is equal to minus 3. This one?
So you push the base to 3n.
Yeah. So 1 over 27
is equal to
3 raised to n.
Yeah.
1 over 27 is 1 over 3 cube.
Mm-hmm.
Correct?
Yeah.
So get that on top. So 3 raised to minus 3.
Because
So same thing happened here, no?
3 to the minus 3 is
Same,
1
same.
over 3.
I missed a step over here. I wrote this as 1000 as this.
Yeah.
And then I got this on top as minus 3. No, because a raised to minus n is 1 upon a raised to n. No, indices.
Yeah. Right. Yeah. Sorry, I was just.
So you change the sign of the
Yeah.
power. Yeah. So what is the value of n therefore?
So n is equal to minus 3.
Equate the powers. Same logic.
So you push it up.
So first you call it n, huh?
Yeah.
Then
Equal
you
to
push
n.
up.
So
256
is equal to 1/4 to the n.
No, 256 is what power?
256 is
So-
4 to the.
So now you can remove guesswork from here.
Yeah.
You want to write the powers of 4, you can take by 4.
Yeah.
4,
Um.
6 are 24. Is it?
Yes. Wait.
4 4s are 16.
Yeah. 6 are
Correct.
64. Yeah.
16.
16.
4 4.
4 1.
Technically you have to take the prime factor, but this is just the power of 4 we are writing.
Yeah.
So this is 4 raised to 4.
4 raised to 4. Yeah.
Acha, what will this be?
4 to the
Minus
minus 1.
Yeah, you are reciprocating, so minus 1.
Yeah.
Remember that.
Say again?
You are reciprocal.
Yeah, right.
A upon b raised to n. If you reciprocal this, the sign will change.
Right, yes. Yeah.
When you reciprocal, the sign will change.
Yeah.
So what is the value of minus n is equal to 4?
Yeah.
Therefore n is equal to minus 4. You are equating the powers.
Yeah.
So minus n is equal to 4. So you have to get the same base. Huh? You have to get at the same level.
Yeah, and it will always be the same, right?
It should be the same whether if it's without calculator.
Okay. Alright.
Call it equal to n. Then
so you push the 8, so 8n.
2 is equal to 8 raised to n.
8 raised to n. Yeah.
Now 2 is equal to what is 8?
8 is 2 to the power of 3.
3.
So
N.
Yeah.
2 raised to 1 is equal to 2 raised to 3n.
Yeah.
So 3n is equal to 1.
3n is equal to 1.
So n is equal to 1.
Okay. Much more clear now.
Yeah.
With the pushing.
Pushing. You have to push to 7. Okay, next one.
It would be x to the 5 is equal to 243.
243 is equal to x raised to 5. Now 243?
That's 3.
Yes, 3, correct. So if you don't know, you go. 3 8s are 24, 3 1s are 3, 3 2s are 6, 3 7s are 21, 3 9s are 27, 3 3s are 9, 3 1s are 3. So 3 raised to 5
Yeah.
is equal to x raised to 5. So what is the value of x?
X is.
Next.
This would be 7 is equal to minus 1/2.
X raised to minus
X
1.
raised to minus 1/2. Sorry.
Now this is important. Now how will you get rid of? You want to solve for x.
I think I know.
Yeah.
You would multiply it by minus 2 on both sides.
Very
to get
good.
rid of the
Correct.
Yeah.
Correct. Good.
So that asks Mr. York.
Yeah. So x is this is equal to how much? This and this cancels.
Yeah.
X raised to 1.
Yeah.
So x is equal to 1 over 7 square.
1 over 7 square.
1 over 43. Then this one.
So this would be
Push.
push, right? So with y is the x. Okay, yeah. So x is equal to
The base will become based on the other. 4 raised to
4 to
minus.
the minus 3 over 2. Yeah.
What is 4?
Oh, it would become
2 squared.
to 2 squared.
Minus 3.
Oh, yeah, that's good.
Correct? This and this cancels. So x is equal to 1 over 2 cube.
Yeah, 1 over 8.
Common log.
Yeah.
A common log is a log with base 10.
Yeah.
It is denoted by log to the base 10 or just log. So whenever there is no base mentioned, its base is 10.
Yeah.
The common log is one of the 2 log functions built in your calculator.
So if it's just log, it's log 10.
10. So this means the log 10. So evaluate. So you call this equal to n, correct?
Yeah.
So 10 raised to 6, this is 1, 2, 3, 4, 5, 6 is equal to 10 raised to n.
Yeah.
So what's the value of n?
6. That's how you do it?
Yeah. With the calculator, you just type in log 20. You have a calculator?
I do, yes.
Yeah, so tell me what's your log 20.
You knew it off the top of your
Yeah,
head.
yeah.
What?
2.3010.
Wow. Actually, you knew it off the top of your head.
Yeah.
Wow.
Okay, now the next set of rules are very, very important. The first three properties are log version of formula property and exponents. Product property,
Yeah.
if you have log m into n, is log m plus log n.
Yeah.
The base remains the same, the base is b. So base remains the same.
Yeah.
So basically your multiplication becomes plus of logs.
Yeah.
Log m upon n, the quotient. Quotient is when you divide. So it will be log m minus log n.
Right. Yeah.
Don't forget the logs. Huh?
This
Every
is
log is
very
important. Yeah. Power property, log m raised to n to the base b. The power jumps in front.
Yeah.
So n log m to the base.
And everything else is the same.
So what you have to do is you have to always break up. So you have to think of the product, you have to think of the quotient, and you have to think of the power. And then you break up.
Okay.
So use the log property. So you must learn this up. Huh? It will require a lot of practice. Log requires lots of practice. So use log properties to expand each expression. So what does this mean?
So this is product property.
Product property.
So it'd be log of 2
log x plus
x
log y
plus log
2 cube.
Don't you need the base? Oh, sorry. You first say x and then
log
you
x
say
plus log y. Base is the same, so you don't worry about the base. And the cube which is there.
Okay.
Now, can you simplify this further? Can the power jump in front?
Yes. 3 log 2 y. And I say the base after, right?
Yeah, base you can put on. Because sometimes focus on the base, so you forget the other thing.
Yeah.
Ajay, this one?
This is quotient property.
So
it'd be log base 4 m.
X raised to 1/3.
X to 1/3, yeah. And then minus
log.
log.
This is x down, x raised to 1/3 like this.
Minus log base 4 y.
So 1/3.
Yeah.
Log x to the base 4 minus log y to the base 4.
Yeah.
Next one.
This is same quotient property. So log there's 3x squared.
What is the base?
It's not there. So
Means
1.
10.
10. Oh right, because if it's not there, it's always
10. So we don't need to write.
Okay. Alright.
Quotient
minus log 5y cubed.
Can you further break this up?
Yes, you can bring the square to the front. So 2.
No, log 3, and then the product rule. Plus log x square.
You can break it down.
Yeah. Minus
log 5.
Log 5 plus log y cubed.
Yeah.
So that is log 3 plus 2 log x.
Oh wow, you can simplify it.
Yeah, you get the power in front using the power rule. The power jumps in front, this one.
Yeah, the square, yeah.
This power which is there will jump in front.
Yeah.
Correct?
Yeah.
Minus log 5. Minus into pluses minus 3 log y.
Wow. Good, yeah.
Now reverse operation. Use log properties to condense this expression. Condense. So what are we doing is, we will look at the log properties in reverse. What does it mean is,
if you're adding it, it's product property.
Yeah.
So you would multiply.
Correct. So basically you're thinking like this. Log m plus log n if you have, you'll do log mn.
In the brackets you just multiply.
Yeah.
So
the base will remain the same.
So this would be log a.
Achha, listen. So if you have log m minus log n will become what?
Log a upon m upon n.
Third, log, if you have n log m, what will become?
It'll become, yeah.
The power jumps
The
on
power
top.
jumps on top.
You're doing reverse of what you did.
Right. Yes.
You're condensing it. So, chalo, so what will this become?
So this would be log base A, 7 times 3.
So that's log 21.
Yeah.
This one?
This one, you're adding it as well, so...
No, first you take the powers.
First take the powers. So
log x cube
plus
log y minus log z raised to half.
Z raised to half. You don't change it. It stays half. The power. Like you don't make it 2 or anything.
How can you make it 2? Half is half.
Yeah.
Half is distinct from...
But isn't it minus half?
No, so minus half is not 2.
Oh yeah, right. So I meant, sorry. Is it, would there be a minus in front of the half or no?
I'm only taking the half on top. I'm leaving the minus down.
Okay. Alright.
Why should you do that?
Yeah.
Now combine it. So log, open bracket,
2
x cube multiplied by
y
divided by z raised
1
to
half.
half.
Z raised to 1 half. Yeah. Interesting.
So that you can
So
write.
this has it combines it and it's also dividing.
Yeah.
It has both.
Oh, everything is there. Power rule is there. First you apply the power rule.
Yeah.
Correct? And get the powers on top.
Yeah.
And then with the plus, then the numbers get multiplied.
Yeah.
If the logs are added, then the numbers get multiplied. If the logs are subtracted,
then they get
divided.
Makes sense, yeah.
Now, given that log 12 to the base 5 is A, log 2 to the base 5 is B, write down the following in terms of A and or B. So first you break it up. You must always break up the thing.
Yeah.
So log 6, how can 6 be written as? Can you write 6 in terms of 12 and 2?
Say again?
Can you write 6 in terms of 12 and 2?
12 and 2.
6 is 12 upon 2.
Yeah. Oh yeah, yeah, you can do that.
So you have to try to write the number which is there in terms of what is given to you.
Yeah.
Are you following that? You have to always try to write this in terms of this and this.
Okay.
Always try to write this in terms of this and this.
Like you have to relate it.
You have to relate it. Yes, that's right. The connection between them. So 6 can be written as 12 upon 2.
Yeah.
Now that's it. Done.
That's it? Okay.
Apply the rule. Apply you tell your teacher, I need to write these properties. The teacher, I need a paper to write all the rules. So this is a paper I'm using. There's nothing now. I'll write the rules. Yeah. So write these rules of logs. Now keep that in front of you. Now this is like your quotient rule, m upon n. Yeah. So what will this be?
So log of 5, 12, and then
log 12 to the base 5.
Right. Sorry. Log. I say it weirdly.
No, you can't say it weirdly.
Minus log to the 2 base 5.
What is log 12 to the base 5?
Log 12 to the base 5.
What is the value of log 12 to the base 5? A.
A, yeah. So
minus,
A minus
what is
B.
log 2 to the, that's B. A minus B. Yeah. That's your answer.
Easy.
Easy, but lot of things. First you have to relate this with the given numbers.
I thought this
then you use the rules of logs. And then you substitute.
You see, I thought this was much more complex because I was absent, right? And I didn't even do the lesson properly. 48, how will you do? How will you try to write 48 in terms of this? 12. You could do 12 times 2 times 2.
Very good, very good. So log 5, 12 times 2 times 2.
Yeah.
So that will be, now use the rules of logs. Log 12 plus
log 2
plus
log 2 base 5.
Base 5. That's it.
That's it. Yeah.
So what is log 12?
Log 12 is equal to A.
Log 2
plus B.
Log 2 B.
You know this because
it's given to you.
A and B, right? Yeah.
They've given to you, and this is your b. This is your b. Now, how will you do this?
Log
50.
Yeah, that's not a factor unless you add 2.
I'll tell you what to do. Now there's one more rule you need to remember for this. 50, can you write it as, so I'll do it like this. First of all, there's one more rule that you need to remember. Log of a number to the same base is equal to 1.
Yeah, I know that. Yeah.
So 5, can you write 5 into 10?
Yeah.
So that's log 5 to the base 5, correct?
Mm-hmm. Which is
plus log 10 to the base 5.
Yeah.
Hmm?
So that's 1.
1 plus log 5. Now what will you do with this? 10.
Could you bring the 10?
10 can be written as what?
Oh,
5 into 2?
Yeah, 5 into 2, yeah.
So we did it too long here. I could have done 25 into this. Anyway, chalo, log 5. 5 into 2. So that's what? 1 plus log 5 to the base 5, correct? Plus log 2 to the base 5. So that's 1 plus 1 plus, what is this? What is log 2? B.
Log
2 plus B.
Because it's equal to log 5
Yeah.
2. Oh, okay, I see. Equal to 2 plus B. Okay, yeah, makes sense. A bit complicated though.
No, but I could have done what? Now the hindsight I'm thinking, that's 50 I could have broken up. Correct? 2, 25. 5, 5s are 25, 5 1s are 5. So log 25, well, log 50 is 2 into 5 square. So base 5, correct? So that's log 2 to the base 5 plus log 5, 5 square. So that's log 2 to the base 5 is what? B.
Yeah.
Plus 2 log 5 to the base 5. So that's 2, B plus 2 times 1. So B plus 2.
B plus 2. Oh, because it's 5 and 5. And the 2 at the front. So you times it 1 by 2. Okay.
So that's another way of doing it.
Yeah.
Acha, now this is very important. Log 1 to any base is 0.
Yeah.
Because if you convert this into index form, you push, na? Push. Anything raised to 0 is 1, na?
So 1 raised to 0.
Yeah. Log of a base, log of b to the base b is 1. That's the rule that I told you. Log of a to the, correct? Yeah. Inverse properties. This is very, very important. Log b raised to x to the base b is x itself.
Because they cancel?
Yeah, you can think like that. B raised to log x to the base b. The base and base basically goes off, you know, and you're left with x. These are important properties to remember, and you might forget them.
Yeah, probably will.
So you have to go through.
Have to watch the lesson.
Yeah, to watch the lesson again and again and again. Simplify the expressions, no calculator. So what will you do now? First tell me.
Simplify
In exams, write all these rules.
So power property.
You write these rules together. Write all the rules together.
Yeah.
Keep the
other properties.
Yes. So that means you have to write how many properties on your paper? 1, 2, 3, 4, 5, 6, 7.
Yeah.
So on a sheet of paper, you must write all of them
together
and learn them up.
Okay.
Write it several times.
Yeah.
Keep that in front of you.
Yeah, I'll keep it like on the side.
But show your teacher because Mr. I'm writing it down. Fine. So let's start.
So simplify. How would I simplify this?
What is log 1 to any base?
Log 1 to any base is 0.
0. We did that, no? Log 1 to any base is
0 is 0.
So 0 plus 0, so answer 0. Next, log 4 to the base 4.
1 plus 1 is 2.
Log 5 to the base 5, 1. So 1 plus 1 is 2. Next.
Can you go up a bit? I just want to see the rule again. 5.
5, correct?
Yeah.
This base and this base is the same.
Yeah.
Then
So you
utilize each
cancel.
other. Yeah, inverse. Yeah. Next,
The bases are the same again.
no, but yeah, the bases are the same again. Yeah, so the answer is 5.5. Next, the bases are the same again.
So is it just
But there should not be any number in front of log.
Yeah.
The leading coefficient should not be there.
Yeah.
So you have to get rid of this 3. How can you get rid of this 3?
2, you mean?
3.
Oh, the leading coefficient for the log, I see.
You get that on top.
Yeah, you can bring that on top. Yeah.
Now you have this base and this base the same. So the answer will be what?
3.
X cube.
X cube, oh, yeah. Sorry, yeah, x cube. Yeah.
Next.
Because it's the power of x cube. Right?
Yeah. Now here what will you do? 27 is what?
3 to the 3 cube.
3 cube. So base and base are the same. So what's my answer?
X. 3x.
3x.
Okay. That's better than I thought.
Yeah.